The next example related to in continuation with the vector triple product show that number one, d bar cross a bar cross b bar dot a bar cross c bar is equal to a bar dot b bar cross c bar multiplied by a bar dot d bar. Similarly, this is again the given statement for the product of vectors. Consider the first one. Usually we start with the LHS and try to find out the RHS, right? So d bar cross a bar cross b bar, it will be d bar dot b bar into a minus d dot a into b. This is with the expansion formula, and the dot is taken over a bar cross c bar. Now individually the terms will be multiplied, right? This term multiplied by this multiplied by this. So d dot b into a dot a cross c minus d dot a into b dot a cross c. But this is particularly written as scalar triple product a bar dot b bar cross c bar, right? Which is also a which is also a box product. Box product is written in the form of determinant, and I know that in a determinant, if any two rows or columns are same, the value of the determinant comes out to be 0. So this can be written, or this particular product is written with the associative property of dot product. Also, whenever you have any scalar into vector dot vector, it can be written as scalar multiplied by vector dot vector. So this is a box product which is scalar triple product, that is a bar and c bar, and I know that this value will going to be, or this value is going to be 0. So this is 0 multiplied by d bar dot b bar or d dot b, which is 0. Only I am left with minus times d dot a into b dot a cross c. So that is how we try to find out and get the result. But this d dot a can be written as a dot d, right? Therefore it is minus times a dot d into b dot a cross c. So if in the product we are trying to change the positions for the vector product, you need to multiply by minus, but here it is just scalar multiplication, so not to worry about it. Minus as it is, b dot a cross c will be written, and then I multiply with a dot d. And now you can consider again the product. A bar dot b bar cross c bar is minus times b bar dot a bar cross c bar. So accordingly I am changing down the positions. This is changed over here and this is brought over here. So minus can be absorbed. So minus times b cross a is written as positive a cross b. So it is a dot b cross c. That is what the property of a vector triple product is. And I think this is intentionally done so as to get the desired result. Similarly, the second one what we have is a bar cross b bar cross c bar cross d bar dot d bar. Initially in the bracket, for this you apply the expansion formula, take the product, b dot d will remain same, it is a cross c, minus b dot c will remain same, it is a cross d. Accordingly, scalar multiplied by the vector is nothing but scalar multiplied by product of two vectors, that is a cross mb is nothing but m into a cross b. Similarly, this dot is attached over here, it is by the distributive property, dot and cross are interchangeable in scalar product, so accordingly I will be writing down or expressing them in the product form. So this is one of the result which we are asked to show. The other example wherein we have to show b cross c dot c cross a cross b is a cross b dot c whole square. That means this particular quantity should be repeated. I now start with the initial term. Now here if you see, there are particularly four vectors given, and that too are appearing in the vector form, right? Our next topic of discussion is going to be vector product of four vectors and scalar product of four vectors, but as of now I am not aware of. मैं इसको थोड़ी देर के लिए क्या बोल दूंगा, p bar, p cross a cross b. I can just simplify it by using the expansion formula, p dot b into a minus p dot a into b. So accordingly it will be p is nothing but c cross a. So c cross a dot b into a minus c cross a dot a into b. Simplify, take the product appropriately, Here also, as it is the scalar product, this quantity will be box product wherein two particular rows are same, so it will be 0. Only I am left with b cross c into this bracket. Accordingly scalar quantity को चेंज कर सकते हो. It will be c cross a dot b. इसके साथ डॉट प्रोडक्ट लीजिए, दोनों आपके जो है वो बॉक्स प्रोडक्ट रहेंगे, और आई कैन कॉल इट एज अ स्केलर product of three vectors, and in the cyclic order they are all equal, and therefore I can say that this multiplied by this is going to be the same term whose square will be written as the final answer. So therefore I am getting down the answer as a cross b dot c whole square, because this is also expressed as a cross b dot c, this is also expressed as a cross b dot c. Why? Because in the cyclic order a b c, a cross b dot c is same as b cross c dot a is same as c cross a dot b. So accordingly you will be getting down the answer. If you are asked to now find out the product a bar cross b bar cross c bar, wherein the vectors are given in the component form. A bar is 2i plus 3j minus k, b bar is I minus 2j plus 4k, c bar is minus 3i plus 5j plus 6k. These are the three different vectors provided to you. Why I am calling it as a vectors? Because they are expressed in the component form. मुझे क्या पूछा गया है? A bar cross B bar cross C bar means this is a vector triple product. Either you can go with the definition, or you can evaluate this particular product of two vectors by the determinant and then multiply it with the second, or expansion formula. What does the expansion formula says? Expansion formula says take a dot c then multiply with b, take a dot b multiply by c. a dot b के लिए, a dot c के लिए क्या होगा? This dot this, a dot c, this is your a, this is your c. So I dot I, j dot j, k dot k is 1. Only you need to take the coefficients product of I as well as j as well as k. Accordingly इन दोनों का product multiplied by the vector b, इन दोनों का product multiplied by the vector c. So scalar multiplied by that vector is going to be a vector quantity, means it is going to involve, or it is going to contain I, j and k. So ये सारे products, vector minus vector is going to be again a vector quantity. Else b cross c आप determinant से निकालिए, उसको a के साथ और multiply करिए, accordingly you will be getting down the same answer. So vector product is obtained in the vector form. That is what the solution we were asked to find out.